All right, in the first exploration, you estimated and calculated the volume of a prism. In many communities, however, water supplies are stored in reservoirs that do not have polygonal bases. So you guys have driven through different communities, and where do you see water stored?
Water towers.
Water towers, water tanks. So what are the shapes of the water towers?
A circle and circles.
Three-dimensional. What is that called?
Cylinder.
Sometimes they're cylinders.
No, it's like it's a ball, sphere.
A sphere.
Yeah.
There you go.
Yeah.
All right. In this exploration, you examine a method for estimating the volume of objects that are not prisms. So, when we're trying to find volume, what's the formula? What's that? Base times height. So, on this, you guys were doing the exact same thing. You were taking the base and multiplying it by the height. So, you have the graph paper. And, oh my gosh, this is not a polygon. It's just an irregular shape. So, step one, determine the area of each square on the graph paper. So, you have several different squares on here. What's the area of this square right here?
1 by 1 centimeter.
Yes, 1 by 1 centimeter. So you have 1 centimeter by 1 centimeter, which gives us an area of what? 1 what? Centimeter squared. All right, count the number of whole squares in the figure. So Maggie, how many whole squares did you get?
96.
96. Keith, how many did you get?
95.
95?
95.
95? 95? Okay. Now, some of us are looking at this and saying, I think this square is whole and this one's partial. So when we're looking at shapes like this, we are not always going to agree on how many wholes and partials we come up with. And that's okay, because we're asked to estimate the volume. So if I have 94 and Maggie has 96, it's okay. We're going to have a volume that's close. Count the number of partial squares in the figure and divide this number by 2. So how many partials did we come up with?
48.
48?
38.
I got 50.
I got 48.
48, 50?
38.
Listen, I like 40.
I have 38, so.
38?
Yeah.
Yeah, I think you failed.
That means.
All right, so we'll go with 48.
Oh, damn.
And then we're asked to divide this number by 2. So 48 divided by 2 gives us 24. All right, so we have looked at the whole squares, and then we've counted the partial squares all around the perimeter. Now again, our partials are going to be different. If your partials are very close to everybody else around you, it's fine. They don't have to be exactly the same. Find the sum of your answers to steps 2 and 3. So, we have 95 plus 24. What does that give us? 119. Then multiply this sum by the area of one square determined in step 1. So we determined that the area of each square was 1 centimeter squared. So I have a total of 119 centimeters squared. What is this 119 representing when we're finding volume? The base. So this is big right here. This is the area of our base. Okay? The area of your base. And your area is going to be close. It might be slightly different than mine. And that's okay. So it's like finding the volume of a cylinder. You have to find the base first. And then we do what?
The height.
Multiply by the height. So, using bases like your geometric figure from part A, imagine a three-dimensional solid 10 centimeters high, such as the one shown below. So, we found the area of the base, and it's 10 centimeters tall. Use the estimated area estimated, that's why we're slightly different, estimated area of the figure found in part B to estimate the volume of the 10 centimeter high solid in each of the following units. So, what do I need to do now?
Times your base by the top.
Okay, take your base, and yours might be different than mine, and multiply it by 10 what?
Centimeters.
And what does that give me?
100, 1,000,
1,000 what?
100.
And?
90.
And what are my units?
Centimeters.
Okay. Now we're asked to determine the number of liters.
Would it be the same?
Is it the same?
No, so we have to change to decimeters.
Okay. So if we go from centimeters to decimeters, how many places do we move our decimal?
One.
But because it's cubed, we move it
2.
3.
3.
3. So if we move our decimal back 3 places, that gives us 1.19 cubic decimeters. And what's the relationship between cubic decimeters and liters? They are the same. Very nice. All right, describe how you would calculate the volume of a prism with bases shaped like triangles, rectangles, or trapezoids. So how do you find volume? Keith?
Times the area of the base by the height.
All right. How do we find volume with bases shaped like hexagons, pentagons, or octagons?
F and base times the
Generally speaking, how do we find the volume?
Half.
How do we find volume?
base times height.
Base times height. So if we have shapes that are hexagonal prisms, octagonal prisms, how do we find their volume?
Base times height.
Base times height. It's all the same. Okay? Regardless of the shape, you always have to find the area of the base first and multiply it by the height.